where can we write all this? In your top left corner, I guess, say A, and it's really the absolute value of A, is your amplitude. Have you noticed that so far, that amplitude's always been a positive number? Or haven't you put that together yet? Maybe not. Well, I'm telling you now. Amplitude itself always has to be a positive number. A in the equation you're going to see can be positive or can be negative. So we'll talk about that. And there are 4 different scenarios. Here's your sine curve. This is a positive sine curve, and we did parent graphs yesterday. The positive sine curve looks like that. Starts on the midline, goes up to a maximum, comes back down to the midline, goes down to a minimum, and ends on the midline. That's the positive sign. A negative sign, what happens when you negate something out in front? Flips it vertically, right? So a negative sign, still going to start on the midline, but it's going to go down first and then come up. So it starts on the midline, down to a minimum, back to the midline, to a maximum, and then ends on a midline. How many points am I kind of defining when I do these curves? 5. There's always going to be 5 kind of critical points I'll be looking at to kind of figure out the accuracy of your graph. Okay, for cosine, a positive cosine, and again, we did this parent graph yesterday, actually started at a maximum, went down, and then came back up. So if you're identifying a cosine curve, you start at a maximum, hit the midline, hit your minimum, come back up to your midline, and then back to your maximum. A positive cosine is a maximum to a maximum. A negative cosine is a minimum to a minimum. Minimum to midline to max, back to midline, down to minimum. So when you're asked to write an equation of a function, you have to decide if you see a sine or a cosine graph. Okie doke? So that's the first thing, and that's where A in your picture might be a negative number. Amplitude, if you're asked for that, still is always the positive version of it, the positive version of A. But if you need to know your actual A value, it could be negative if it starts down first in either the cosine or the sine case. Your B is your horizontal stretch or compression. Okay? And we talked about this yesterday, but if we horizontally stretch or compress something, what changes? The amplitude, the period, or the midline? The period, right? So B is not the period, but we calculate the period from the B value. So an equation that you're going to need to know that'll definitely go on a flashcard is that the period is 2 pi. That's what it starts at. But if there's a B value and it got stretched or compressed, your period changes into whatever 2 pi divided by B is. So period equals 2 pi over B. Ooh, C is not your midline. Cross this out. I have to make a change for next year. I already changed it once. I just didn't update that. C is your phase shift, we're calling it. It's only called a phase shift in trig. In any other aspect, that's your horizontal shift. And then D is your midline. So D is your midline. And that's because that's the vertical shift. If you shift this thing up or down, your midline shifts with it. So, when we look at a graph, and we'll just jump right into writing our first one. if at all possible, you do not want a phase shift. You want your cycle to start right here. So when I'm choosing a cycle, if it's possible, I want it to start at 0, and then this cycle would end here. Is that fair? Start of your cycle, end of your cycle. Yes? First thing you need to identify, is this a sine or a cosine curve? Cosine. Is it a positive cosine or a negative cosine? Positive cosine. So it's definitely a positive cosine. I'm going to leave some space in there for my A value, which I don't know what of these A's, B's, C's, and D's you're going to want to look at first. Maybe it's easier for you guys to find your midline first. So I'm going to do this. A cosine B x minus C plus D. I'm just going to get my structure there. And then maybe it is easy to find the midline first. Where's the midline? If the max is at 3 and the minimum's at -3, what's the middle? 0. Okay, so D is 0. This curve starts at 0. It hasn't been shifted over at all. Does everybody see that? I have not shifted this curve over at all. It starts at 0. That means the phase shift is 0. So x minus 0 as well. Now for B and A, well, A is our amplitude. Can we get that? If our midline is at 0, what's our amplitude? 3. And we already decided that A was positive because this is a positive cosine. So positive 3 cosine. And then the last thing is figuring out B, which comes from your period. So when you look at this curve, Jason, what is the length of the period here? 4 pi. So if your period is 4 pi, we're going to use that to calculate B. We can see, if we're looking at the graph, we can see what our period is, and then we're going to use this formula just to solve for B. So just kind of cross multiply, put the 4 pi over 1, and then cross multiply, you'll get 2 pi equals 4 pi B, and then Owen, what do I have to do to both sides to get B all by itself? Divide the 4 and the pi over, right? The pi's will cancel, which is nice, and B is just 2/4 or 1/2. So I figure out what A, B, C, and D are, and I'm pretty much done, although we might clean this up a little bit, because who needs the plus 0 at the end? If you see x minus 0, you don't really need that either, and this ends up just being 3 cosine of 1/2 x. Okay? Any questions on that? So if you think about the transformations we talked about yesterday, this transformation happens first. Describe that for me, Jackie. Now shift. Shift for when you add it to the graph. Correct by 2. Correct. So it's hard to see because my cosine curve would start at 0 at a maximum, end at 2 pi at a maximum, and have a minimum at 1 pi. In the grand scheme of things, that's my cosine paragraph. They have the scales that they do, right? Starts at 0, ends at 2 pi, max of 1, minimum of -1. Good? This horizontally stretched it by 2. So this point that was at 2 pi gets doubled up to 4 pi. That makes sense? This point that was at 1 pi gets doubled up to 2 pi. This point that was right on the y-axis stays on the y-axis. This was technically at pi over 2, so that doubled up to pi. And then the one that was at 3 pi over 2 doubled up to 3 pi. And after just the horizontal stretch, that's what this looks like. Can you see that? just picture that curve as like a rubber, stretchy rubber band, and I just stretch it out to a degree. And it's stretching from the y-axis, which is why this point remains fixed. Does that make sense? So it's going to sort of visualize that. And then the next transformation in the left side is what? Vertical stretch by 3. So now I'm going to take the green point that I left off that, and I'm going to triple it. So that was 1. I'm tripling that up to 3. This was right on the x-axis, so if I'm stretching from the x-axis, it's fixed, right? This was at -1, so I'm pulling it down and tripling that. It's going to pull down to -3. This one is fixed, because I'm stretching from the x-axis, and it's already on it. And this one was at 1, so it stretches up to 3. And you can see transformation by transformation how that actually is the graph that we just wrote to equation. Follow? Okay? You're not going to do that on every problem, but I think it's conceptually important to kind of see how that transpires slowly, transformation by transformation. That was only 2 transformations, so that was a little more bearable. All right. Number 2. If you can start on the y-axis again, do it. So this goes up, comes down, and that's where your initial cycle would end. And really, you only want to focus your eyes in on one cycle. You don't want to let the rest of the graph confuse you. So let's get started. Natalie, sine or cosine curve? Yeah, look at your 4 main pictures at the top. Cosines are like U's or upside down U's, right? This is a what? If you compare that to the 4 pictures at the top of your paper, positive sign, okay? By the way, guys, this is going to be a flashcard too. I'm going to have, like, you draw the positive sign, the negative sign, the positive cosine, the negative cosine parent graph, just shape. Because you have to be able to identify those. This is a positive sign. So I'm going to go right into positive A sine B, x minus C, plus D. Thank you. Let's start with Lucas B. What do you like to identify first, or anything, Lucas? The A, the B, the C, or the D? The amplitude, the B value, the phase shift, or the midline? Midline is what? 0 again. Goes up to 3 and down to -3, so the middle of that is 0. Good. Lucas K. What else can you tell me? Three. So we'll just put that in there. Very good. Those are probably the 2 easiest to start with. Bella, what would you do next? Okay, so which is that going to help us find, B or C? Right. That's not what you plug in for B, but it helps you calculate B. Follow? So period equals 2 pi over B, and she's saying the period is 4 pi, which is exactly what it happened to be the last time. Cross multiply, and you're going to get B equals 1/2 again. And then C, Eric, is what? Right. This sine curve that we've identified has not been shifted left or right off the y-axis at all. Okay? Hopefully our phase shift will be 0 90% of the time. Okay, so this ends up just being 3 sine of 1/2 x. Any questions? All right. Number 3. Think about first if you're going to identify this as a sine or a cosine, and then whether you're going to identify it as a positive or a negative version of that. And then I'm going to call on someone. Jack T, what would you say? Did you hear the question? Are you too far away from me? Do you need to move closer? Okay. Just a moment, right? What are we going to identify this curve as? A sine or a cosine? Positive or negative? Correct. So if you start right on the y-axis, you got that from the cycle starts here. It's going down first, coming back up to the midline, going above the midline, and back down to the midline. This is the section that is, if you compare the 4 pictures at your top, that's a sine curve, but a negative sine curve. Negative a sine of b, x minus c plus d. Okay? Tell me something else, Sierra with a C. The midline is 0, max is 2, minimum is negative 2, good. Sierra with an S, tell me something else. The amplitude is 2. So it's a negative 2 this time, right? But the amplitude is 2. It's just because it's a negative sign, we have that negative out in front. The A value technically is negative 2. And that's tricky. You've got to pay attention to questions and how they word it. If the question says, what is the amplitude? 2 is the answer. If it says, what is the A value? Negative 2 is the answer. Okay, so be careful about how you read that. Tell me something else. Tess? B is 2. So she's already done the work. She knows that the period is what, Tess? The period is pi. That whole cycle is completed by pi. So she has already taken the liberty of plugging in the pi. Did you already do this on your paper? She already plugged in the pi for the period, and she's already cross-multiplied and solved for b, so that she could divide both sides by pi and find out that b is 2. Nice job. And then x minus, there is no phase shift, right? Our cycle started on the y-axis, so there's no phase shift. So this ends up being negative 2 sine of 2x. Any questions? Let's jump to the back. See what we have here. Oh boy. Let's look at 6. You guys have a back, right? Oh, okay. I heard murmuring. I got nervous. All right. On number 6, if someone asked you to identify that as a sine or a cosine curve, wouldn't you think, I have no idea? That's not a full anything, right? They're only showing you a piece of it. So if you were guessing, what would we do from here if we were to continue this curve? Where would we go with it? Down, and then we would eventually get to a minimum, right? And then we would come back up and get back to a positive again, right? Now what kind of curve is it? Positive cosine. Positive A cosine B, x minus c plus d. That structure you guys definitely are going to have to know. That's going to be another flashcard. I'll give you an updated list tomorrow. So, we already know it's a positive cosine. Because they only labeled the first part, we need to kind of now label these next critical point. Like the minimum, where's that happening? If this is happening at pi, where's this happening? How would I label that? 2 pi. And then the next critical point is happening at 3 pi, and the last critical point is happening at 4 pi. So our period is what? Our period is what? 4 pi. So period equals 2 pi over b. 4 pi equals 2 pi over b. Cross multiply. Divide by 4 pi. B is a half. Got it? Chloe, tell me something else. Midline is 0. Excellent. Tell me something else, Georgia. Amplitude is 2. And phase shift is 0 again, right? Our cosine curve started right there. So 2 cosine of a half of x. We got to do one where we have a different midline because we've had all midlines of zeros. So back it up to number 5. So if we start our curve, Jack B, what kind of curve, starting right on the y-axis, what kind of curve is this? Negative cosine, very good. Negative a cosine b, parentheses, x minus c plus d. Negative cosine. Now we got to start plugging in a, b, c, and d. Tell me something, Kate. Now, I almost find it hard to believe that we can get the amplitude without first at least processing the midline. Did you do that mentally? You kind of think, yeah. So tell me what the midline is first. 3. Just kind of put that midline right through the middle of your graph, and the midline is at 3. So that's a plus 3 at the end. And then from there, she's grabbed her amplitude of this max is 2 units above the midline. There's your amplitude. So that's a negative 2 cosine. Not what's the b, but what is the period of this? Haley? 16. So period equals 2 pi over b, and period is 16. So I'm going to plug in a 16 for p. Cross multiply, I get 16b equals 2 pi. Divide both sides by 16. And b equals 2 pi over 16 will become pi over 8. That's fine. B doesn't have to be a regular number. It can be a number in terms of pi. So it's a little bit quirky, and it's hard to wrap your head around. We've actually horizontally stretched this by a factor of whatever the reciprocal of that is. You would never have to describe that one. And then our phase shift is again 0. So this can be cleaned up and written as negative 2 cosine of pi over 8x, and then the plus 3 at the end. You don't really need that x minus 0 in parentheses. Good? If I were to show you something like this, y equals 3 sine of 2x minus 4 plus 1. I'm just going to, just bear with me here. I'm going to ask you a new question. What if I asked you, what's the maximum value this graph ever reaches? Raise your hand when you think you can tell me. What's the maximum? Like this graph reaches a maximum of 1, 2, 3, 4, 5, and a minimum of 1. What's the maximum this reaches? And again, this is obviously without me teaching it, but 3 of you, 4 of you think you already know, which is good. So I'm hoping that logically you can figure that out. Elena, God, I haven't called on you yet today. What would you say the maximum is? You think 4, and how did you logically reason through that? Because you're correct. Perfect. Does everyone make sense of that? Raise your hand if that's what you thought. Good. Those of you who had your hands creeping up, you're accurate. So the midline is 1, and the amplitude says we're going to go 3 above that, which puts us at a max of 4. And the minimum, therefore, would be what, Jack B? Nope. If the max was 4 and the minimum was -4, the midline would have to be 0. Our midline is 1. We're going 3 above it, which got us to 4. What'd you say? No, and 3 below it to get to our minimum. -2. Good? So kind of asking you, and you know, those features, like clearly you already know, but that's just a different way I've seen it asked before. All right, we'll probably start tomorrow with this word problem at the bottom because it's kind of what we're getting into. I'm going to hand out your homework, but before I do, year after year, I'm convinced that the 6-point question is going to be like writing a trig function because it's one of those things that really has like real life applications. So but not a ton. Not a ton of real-life applications, which is a good thing because they use the same applications and word problem types over and over again. Starting with, and I just came up with some examples. If you think about the average number of hours of daylight throughout the year, that's a cyclical thing, right? In December, we have the fewest hours of daylight. And then as we go through the year, that increases. And right now, as we're in February and March, it's increasing pretty quickly, right? Have you noticed it getting brighter outside? And then as we get to May and June, it's still increasing, but we don't really notice it as much because it's really starting to slow down. Because when we reach June 21st, right, our number of hours of daylight starts to decrease until we get to December 21st again, and we're at the bare minimum. And then that's a sine trig cycle. Actually, that's a what kind of cycle? Sine or cosine? Cosine. So we'll use these trig functions to model real life scenarios. Here's another one they use a lot. High tide and low tide. If high tide and the depth of the water is highest at midnight, you've gone on vacation and seen high tide, low tide schedules, right? But it's not on a monthly schedule like the hours of daylight. It's kind of like on an hourly schedule. So this would be a positive cosine curve. And the period for this is 12 hours. Truthfully, the period for a real high tide, low tide thing is like 11 hours and something. It's not exactly 12, but we get the idea. Lucas, did you end up with the extras?